Bismillah ar-Rahman ar-Rahim. Let's look at this different problem than the one we solved in the last video. Determine the magnitude of the component force F. This is the same force acting along. Now, it has the same thing. Before it was acting along the cable AC or line AC. Now, acting along a segment. Segment this. So let me just erase this. This segment. Segment BC. So let's look at the coordinate BC. What is B? You can see the B is 3, 4, 0 feet. And C, what's C? C, it is 7. And in the Y, it is 6. In the Z, it's -4, right? Minus 4. So you look for the position vector CB from the force, from the tail of the force. It is CB, which means B minus C, 3 minus 7 minus 4, 4 minus 6 minus 2J, 0 minus 4, it's plus 4K. And that is the position vector in feet. The magnitude of that position vector, it's square root 4 square plus 2 square plus 4, 16 and 16, 32, 32 and 4, 36, so it is 6 feet. So the unit vector it is -4 over 6I minus 2 over 6J plus 4 over 6K. That is unitless. Later on, we want to find now along, parallel, along. So what we do? You do the dot product. The force on the piece of that segment BC is equal. Of course, you dot the force. (30I minus 45J plus 50K) dot unit vector CB -4 over 6I minus 2 over 6J 4 over 6K -4 over 6I minus 2 over 6 plus 4 over 6. And that's, you just multiply now this times this. So it is 30 times -4 over 6 minus 2 over 6, 50 times 4 over 6, and that's what give you let's just 28.3 pounds. This is the force projection along or parallel to the segment BC. Now, the next one is to find the component of the force perpendicular to the segment BC. So remember that we have parallel or along, now perpendicular. If you look at the note, just do this in a different color. The note shows that the force, the actual force, this force, in a scalar format, square is equal the force along the line under study square plus the force perpendicular to that line square. So we don't have this, but we have the Cartesian format. Let's find the scalar force. It's 30 square plus 45 square plus 50 square, 45 square, 30 square. That is square root 5425, and that is in 5425 square root bound. Okay. We have the force along the segment. So F square, it's a square root, so F square, it's 5425. 5425. FCB square, 28.3 square, plus the force perpendicular to the segment CB square. So FCB perpendicular is 68 pound. So now imagine here he wants the magnitudes. Imagine he asks you for the force along the line, not in magnitude format, but in Cartesian format. Okay, so we'll do it like this. Force CB. Oh, did I do here? I'm not supposed to do direction here because it is magnitude, sorry. So the force along the line CB in Cartesian format, 28.3 times the unit vector CP. Let's say he asks you to find the force perpendicular to the segment CP in a Cartesian format. So you have it here, 68 times the unit vector, this is the unit vector for the segment. Let's find each one of them. So let me just open my calculator. I think I could do this here. 4/6 plus 4/6. This is minus 45.3i minus 22.7j plus 45.3k minus 45 minus 22 plus 43. Okay, this is in pound, of course, and the other one, which is the okay, so 4/6, that's in a minus times 28.3, that's minus 18.9 I 2/6 times 28.3, and that is minus 9.43j 4/6 times 28.3, and that is 18.9. Okay, this is in pound. So we found both forces, one along the segment BC, one perpendicular to the segment CB, one in magnitude and one in the Cartesian format.